Good day once more, students. Today I would like us to look at the BAMBERGER rearrangement. What does the BAMBERGER rearrangement entail? The BAMBERGER rearrangement entails that you've got a phenyl hydroxyl amine that you start off with, which you treat with what? Which you treat with your strong acid, right? That is in the presence of what? Of water, right? To generate what we refer to as the what? As the 4-amino phenol. That's what the BAMBERGER reaction is all about. In a nutshell, what you are doing in a BAMBERGER reaction, here, you've got your OH group, here, and then in this carbon atom here, you've got your hydrogen atom there, you've got a proton there. So what you are doing now, like, you are taking this OH group to come and substitute this proton, that is, to come and substitute this proton that is here. The proton that is here, you are taking it to go and occupy the position that was occupied by your OH. That's what the BAMBERGER reaction is all about. But how does this reaction actually take place? Here, you've got your hydroxyl group here that goes out to pick up a proton that is from your acid, right? Then as this one is coming to pick up this proton, then your oxygen, which is positive in charge, it takes away the bond pair that it shared with hydrogen to generate water that side as your product. Then the hydrogen that was here, it comes in here to generate water inside the structure, right? Now the oxygen that we had here was neutral in charge. Now it becomes what? Positive in charge, isn't it? Right. Now we end up with having water inside that structure. So here you have your OH. So your OH was a bad living group in this structure. Your water in this structure becomes a good living group. Then it leaves. So this bond between oxygen and nitrogen breaks because oxygen is much more electronegative than nitrogen and it is bearing a charge. Then it leaves. So water leaves there. So when water leaves here, there, nitrogen becomes positive in charge. So the nitrogen that has become what called positive in charge, what then happens to that nitrogen, to that positive charge, is that it is stabilized by what? By the benzene ring. Remember, the benzene ring is rich in terms of what? Of electrons. So here you've got a positive charge, a single bond, and a double bond. Then there's going to be conjugation. Conjugation, it means that now the electron density of your phenyl ring, of your benzene ring can move. Then it moves to form what called a double bond here. So between these two carbon atoms that we have here, one of these carbon atoms loses the electron pair. And once it loses the electron pair, it becomes positive in charge. So between those two carbon atoms, it is this carbon atom that loses the electron pair. Then this carbon atom becomes what in charge? Positive. So again here you've got positive charge, single bond, and a double bond. Double bond being the source of electrons. Again you've got conjugation. Then this moves again to get another resonance structure. Now between these two carbon atoms here, the one that loses electrons, it's the one below. Then that one that loses electrons, it becomes positive in charge. Again, you've got a positive charge here, single bond, double bond, then you're also supposed to get another movement. But whatever structure that I'm going to get this side, it's going to be equivalent, or it's going to be the same as this structure, but really written in another orientation, but it's the same structure. So that's why I end here. Now remember we said we are moving this hydroxyl group from this position away from nitrogen to this carbon atom. Therefore, it's quite logical for us now to look at this structure now in terms of our resonance hybrid that we are going to continue with, right? So there's my carbon atom there, which is positive. Now it's going to be attacked by water. Remember, this here gave us this structure plus water. Now there's our water attacking this carbon atom that is positive here, right? So we're bringing in electrons to this carbon atom. There's a bond that has been formed here. This oxygen was neutral in charge. Now oxygen is what now? Positive in charge. Then this oxygen, which is positive in charge, and more electronegative than hydrogen, it takes away the bond pair that it shared with what? With hydrogen. So this hydrogen here, it falls off. Now we have introduced the OH group in that carbon atom, right? But on that carbon atom, there is also another hydrogen which has always been there, right? Now, what happens now, like with this structure that we have formed here, right? This structure wants to form NH2. That is, the benzene ring wants to go back to its original state where it had three, what we call like bonds inside. So what's going to happen now, like the nitrogen carbon bond breaks. So as it breaks, it comes in here to pick up this proton on this carbon atom. It picks this hydrogen as a proton, as a positive, right? So meaning that now, like this carbon atom here, it's the one that loses electrons between carbon and nitrogen. It's the nitrogen that's going to pick up this to generate NH. So this carbon becomes positive in charge. Positive charge, and then single bond, double bond source of electrons. There's going to be a movement of electrons to give us a double bond here. So between these two carbon atoms, which one loses electrons? It's this one. So remember now, like with your hydrogen atom here, that left behind its pair of electrons. Then it is this pair of electrons now, like that is used to form a double bond in this position, right? Then now, like our benzene ring now, like is intact again. So economically, what has happened here is, in place of your OH that was there, now the OH is replaced by what? By hydrogen, by a proton. In place of a proton that was here, the proton has been replaced by what? By your hydroxyl group. So that's that trade-off in this case. It is that rearrangement that is known as what? As the Bamberger rearrangement, generating what we call a 4-amino phenol. Thank you very much. Remember, organic chemistry is easy, organic chemistry is beautiful, organic chemistry is fun. Do not fear organic chemistry. Do not fear these funny structures. All that you have to do, look at the movement of your electrons. Look at your arrows. That's the most important thing with organic chemistry, right? I'll see you in the next class. Thank you very much.